In this lesson, we're going to continue where we left off with simplifying rational expressions, and now we're going to just add the skills of multiplying and dividing them. So by the end of this section, you should be able to multiply rational expressions and simplify them as much as possible. Also divide rational expressions and simplify as much as possible. And finally, what we've been practicing, which is stating restrictions on the expression. So to help us multiply and divide rational expressions, we're just going to start with some rational numbers, so some fractions. And we've been doing this since elementary school, multiplying fractions and dividing fractions. So let's just go through the steps of multiplying a half and 3/4. So if you remember, when we're multiplying fractions, all we're going to do is multiply the numerators and then multiply the denominators. So on the top, we're going to have 1 times 3. And on the bottom, we're going to have 2 times 4. And that is just going to simplify. 1 times 3 is 3 all over 2 times 4, which is 8. And that's our final answer. So when we multiply rational expressions now, so with polynomials, we're going to do the exact same thing. We're going to multiply the two polynomials in the numerator. We're going to multiply them in the denominator, and we're just going to simplify. So we're going to find that it's much easier to factor them first and then do the multiplication. For division, we know it's super similar. What we're going to do is instead of dividing 1 divided by 3, we're going to change this sign to multiplication by flipping this second fraction here. So we're going to create its reciprocal. So we're going to leave the first fraction on its own. So we have 1/2. We're going to flip the second fraction. So we have 4 over 3. It's reciprocal, and then we're going to change the sign to multiplication. And now we're going to do exactly what we did in the previous example. We're going to multiply the numerator, multiply the denominator, and we're done. So we have 1 times 4 on the numerator, 2 times 3 in the denominator, which will be left with 4 over 6. And then we can simplify that to 2 over 3. So we're really just going to follow those steps when we're dividing a rational expression. So we're going to, if we're dividing, we're going to create the reciprocal of our second fraction. So we're going to flip it, change our sign to multiplication, and then we're going to multiply the numerator, multiply the denominator, and simplify. So if any time during the lesson you forget the steps and you're not sure what to do, just change the polynomials to just numbers. So we're dealing with rational numbers. And what would you do there? You're going to do the exact same thing in your rational expression example. So some quick tips for multiplying. We're going to start with multiplying because it's a little bit easier. We don't have that extra step of flipping the second fraction. So here are my suggested steps. The first suggestion is to simplify and factor first before you multiply. So simplify and factor the numerators and the denominators. And then you're going to multiply the numerator and then multiply the denominator like we did here. Cancel out common factors like we've been practicing and determine any restrictions on the variable. So now we're ready to get started on our first example. So following the steps, we know we're going to simplify. By the way, we have two rational expressions here and we're multiplying them. So following our steps on the previous page, the first thing we're going to do is we're going to factor. But I've got monomials, so just one term in each of the denominators and numerators. So there's nothing to factor. So we're going to skip ahead to part 2, which is we're just going to start multiplying these fractions. So I'm going to multiply this term by this term, and then this term by this term. So in the numerator, we are going to have 3x cubed times 8y squared. So we can multiply the 3 times the 8. We know that that's just 24. And then we have x cubed and y squared. And in the denominator, we've got 2 times y times 9 times x. So we can simplify the 2 times 9. We know that that's just 18. And then we have an x and a y. Notice that I flipped these. You can put y times x. It really makes no difference. It's just sometimes easier if you write it in alphabetical order. Because if you follow that pattern, then sometimes our letters will match up a little bit easier and you can better see what you can simplify. So we're on to our last step now. We've multiplied. Now we're just going to simplify. So I'm going to simplify them. I'm going to write my fraction bar, and I'm going to do one at a time. We're going to simplify this 24 over 18. So there is a common factor. The largest common factor is 6. So I'm going to divide by 6 in the numerator, divide by 6 in the denominator, and we're going to be left with 4 over 3. And now we're going to work on our x's. So we know that there's an invisible exponent to the power of 1 here. So when I simplify these x's, we have x to the power of 3 divided by x to the power of 1. So we're going to subtract those exponents because it's the same base in division. So we have 3 minus 1, which is going to be x squared. And then finally we have our y term. Again, we have our invisible exponent 1. And we've got y squared divided by y to the power of 1. So we're going to do 2 minus 1 following our exponent laws, where we have y to the power of 1. So our final answer is just 4x squared y all over 3. So we have this complex expression is equal to this more simplified expression as long as we include the restrictions. So it's starting up at the top. We're going to have restrictions for y, and we're going to have restrictions for x. So I'm going to say x cannot equal and y cannot equal, and then we're going to fill in the blanks. So taking a look here, I can see that if I change y to 0, we'll have 2 times 0, and then the denominator is 0, and we have a problem. So we know that y cannot equal 0, so I'm going to add that down here. Moving on here, I've got 9 times x, and if x is 0, then 9 times 0 will make 0, so x cannot equal 0 either. And as we continue down, let's take a look if there's any new restrictions that come up. So we have x and y, again, neither of those can equal 0. We already have that, and there's no restriction here, no restriction here. So this is our final answer. So now let's work on an example that's slightly more complex. So we've got 2 rational expressions, one here and one here. So our first step is to factor. But the lovely thing is everything's been factored for us. So let's just take a look up here and make sure that nothing else, nothing else in common we can take out. We have a 2 times x squared times y minus 1. That's all factored. And then at the bottom we have 3 times x plus 5. And at the top of this fraction we have everything factored as well as in the denominator. So we can skip the factoring part because it's already done and move right to multiplication. So remembering when we multiply, we're just going to multiply the numerators and multiply the denominators. So taking a look here, if there's anything we can simplify, we have 2 times x squared times y minus 1 times 6 times x plus 5. You do not want to distribute. And the reason why you don't want to distribute this is that you're undoing the factoring. We want it to keep it factored because then we can cancel out factors in the numerator and the denominator that match. So now we're ready to multiply, and we can see that the 2 and the 6, when we multiply those together, that can simplify to just 12. And then I have an x squared, I have a y minus 1, and I have an x minus 5. So I've listed all of the factors here, and I've just simplified one. So I have 2. That was taken care in the 12 because we have 2 times 6. I have the x squared, I have the y minus 1, and I have the x plus 5. In the denominator, there's nothing really that we can sort of collapse together or collect. We've got a 3, an x, a y squared, and an x plus 5. So I'm just going to rearrange it so that the monomials are first. So we have x, y squared, and then x plus 5. And I just realized I missed a plus there. Okay. So now we can take a look at what we can simplify. So if there's any common factors. So I see an x plus 5 in the numerator and an x plus 5 in the denominator. So we know that we can cancel those out. I also see numbers that we can simplify. We know that 12 divided by 3, that can just simplify to 4. So I'm going to start recording our final answers below. So 12 divided by 3, we know that that's just going to simplify to 4. Now let's work on the x's. We have x to the squared divided by x to the power of 1. So we're going to be left with x to the power of 1. And then up at the top, we are still left with a y minus 1. So I'm going to copy the y minus 1. And then at the bottom, we've dealt with the 3 because we did 12 divided by 3, that makes 4. We've dealt with the x because we simplified these two terms, but we still have a y squared. And x plus 5 was canceled out. So we have our final answer here. Our final answer is going to be 4x y minus 1 all over y squared. There's no more common factors. We know that because we fully factored the numerator, fully factored the denominator, and there's nothing else that they have in common. So all we're left with is finding the restrictions. So these two expressions are equivalent as long as we include the restrictions. So taking a look up at the top. Remember, we're just looking at the denominator, so we'll look at this denominator than this one. So I see we've got 2 variables going on, so we're going to have 2 sets of restrictions, what x can't equal and what y can't equal. In our first bracket here, We know that x cannot equal negative 5 because if it is, negative 5 plus 5 will make 0. So x cannot equal negative 5. Moving on, we know that x also cannot equal 0. So we have 0. And y also cannot equal 0. And those are our final restrictions. Just as a side note, it's always a good idea to just take a look at the rest of the equations, make sure that there's no other restrictions that we missed. So here we have x can equal negative 5. We have that. X can equal 0. Y can equal 0. We have that, as well as y can equal 0 here and here. Now we're going to look at a slightly more complex one where we've got 4 different polynomials in 2 rational expressions. So we've got to follow our steps or suggestions to simplifying this. And the best thing to do is factor everything separately, put it all together, and once it's factored, we can start multiplying. So I'm just going to label each of these 1, 2, 3, and 4, and I'm going to factor them on the side and come back and put them back into our equation or into our expressions. So pause the video, factor them on your own, and then come back. So now that you've got everything factored, you should have something that looks like this. And now that we have all of our numerators and our denominators factored, we can multiply them together. So in the numerator, we're going to have 4 terms or binomials all multiplying against each other. So we've got 1, 2, 3, 4, all multiplying. And remember, you're not going to expand this because we want everything factored so we can cancel it out. So we have x plus 3 times x plus 2 times x plus 6 times x minus 5. And in the denominator, we also have these 4 binomials multiplying against each other. So we have x minus 3, x minus 2 times x plus 6 times x plus 3. And now we're ready for the fun part, which is crossing out term or common factors in the numerator and the denominator. So I see an x plus 3 and an x plus 3 in the numerator and the denominator, so that's going to divide and make 1. I also see an x plus 6 and an x plus 6, and that's it. So what we have left over is we don't have an x plus 3 anymore. We have an x plus 2 and an x minus 5 in the numerator. So x plus 2 and x minus 5. And in the denominator, we have an x minus 3 and an x minus 2. X minus 3 and an x minus 2. So we've taken this really ugly rational expression and simplified it to something much prettier and much smaller. So these two are equivalent as long as we include our restrictions. So taking a look at the top here, we can see the restrictions very difficult to see because it's not factored. So let's take a look down here. So I know that I only have one variable, so I'll just have one variable here, x. Taking a look here, we know x can't equal 3, x can't equal 2, negative 6, or negative 3. So we're going to write 3, 2, negative 6, or negative 3. We're just going to check through again, make sure we haven't missed any. 3, 2, negative 6, negative 3. We've got those. We have 3 and 2, so we have everything here. So now that you've mastered multiplying, dividing is so similar. We remember when we were dividing those two fractions that the only difference is we're going to find the reciprocal of the second fraction and change it to multiplication. So we're going to do the same step. First, factor the numerators and the denominators. And there's a good reason to do this, which is if you forget to factor first, sometimes you're going to miss some restrictions. And I'll show you what I mean by that. Then we're going to multiply the reciprocal of the divisor. So we're going to flip and multiply that second fraction. We're going to multiply as usual, cancel out common factors, and determine restrictions. So let's start off simple with this example here. So we've got 2 rational expressions we're going to multiply. Our first step is always to factor, but we have all these monomials here, so there is nothing to factor. So the second step is we are going to flip this second fraction so we can change it to multiplication and actually simplify this. We have negative 3a cubed over 7, that's going to remain the same, times, and we're going to flip this second fraction to 21 all over 12a to the power of 5. And now this is just like a question that we did in the previous examples. Now we're just multiplying this numerator by this numerator and then this denominator by this denominator. So I'm going to set up my fraction bar and I'm going to multiply negative 3 times a cubed times 21. So So I know I can multiply negative 3 and 21, and I'm going to get negative 63. And then I also have an a cubed, so I'm going to put a cubed here. And then next I've got 7 times 12 times a to the power of 5. So I can simplify 7 times 12, because we know that's going to be 84. And then I have a to the power of 5. And now we're ready to just simplify. So we've got this fraction, negative 63 over 84. We're going to reduce it because both are divisible by 21. So I'm going to divide by 21 and divide by 21. And we're going to be left with negative 3 all over 4. And now we're going to deal with our a values. So we have a to the power of 3 divided by a to the power of 5. So we're going to subtract 3 minus 5, and we're left with a to the power of negative 2. So we can't leave our final answer with a negative exponent. So we're going to bring this a to the power of negative 2 down to the bottom of the fraction like we practiced, and change the exponent to positive. So our final answer on the top in the numerator will have a negative 3. In the denominator we're going to have a 4. And our a is going to be brought down. So we're going to be left with a to the power of positive 2. And this is our final answer. So next we're going to add our restrictions. So a cannot equal, and we're going to take a look upstairs. So we've got no restrictions at the beginning of this question. However, when we flipped it, an a is now in the denominator, so we've got to include that in our restriction. So no, a can't equal 0. And if you take a look throughout, there's no more restrictions. So we have a cannot equal 0, and this is our final solution. So let's take a look at the next example. So we're dividing two rational expressions. So we got to make sure that we factor all of the expressions. We're going to factor the numerator and the denominator of all these fractions. I can see that we've just got some common factoring here. So I'm not going to worry about side work. I'm just going to do everything in here. Okay, so I know in my first expression I can factor it at 2. So I'm going to common factor it at 2, and I'm left with x plus 3. In the denominator, it's just a monomial, so there's nothing to factor. And then we've got divided by, before you flip them, factor it first, just so that we don't miss out on any of the restrictions. So we have, on the top, we're going to factor it a 5, and we're going to be left with x plus 3. And at the bottom, we're going to factor out an x, and we're going to be left with x minus 3. Okay, so now let's deal with this division sign. So we know to divide two fractions, we're going to flip the second fraction and multiply. So we're going to rewrite. It's 2x plus 3 all over x to the power of 3. We're going to change the sign to multiplication, and we're going to flip. So we have x minus 3, then 5x plus 3. Okay, so now we've done the hard part. Now all we have to do is multiply. So we're going to multiply the numerators and then multiply the denominators. So I'm going to make one big fraction bar. And if we take a look here, there's nothing we can really simplify. We've got 2 times x plus 3 times x minus 3. I'm just going to put the 2 and the x together on the side. And then we have x plus 3 and x minus 3. And at the bottom, we've got x to the power of 3 times 5 times x plus 3. So I'm going to put the 5 and the x cubed first, and then I have x plus 3. Okay, so now's the fun part. We just get to look for common factors. So I see an x plus 3 in the numerator and an x plus 3 in the denominator. So those are going to cancel out and make 1. And then I've also got these x's to deal with. I know that I've got an exponent of 1, so I'm going to subtract those. In terms of the 2 and the 5, there's no common factor between the two of them, so we're going to leave them alone. So up at the top, I've got a 2. And when I subtract these two, 1 minus 3 is negative 2. So I'm going to have x to the power of negative 2. I've crossed out the x plus 3, and I'm just left with x minus 3. At the bottom, we have a 5. The x to the power of 3, we've already taken care of it by subtracting 1 minus 3. So it's here. And we have no x plus 3. So we cannot leave this as our final solution because we have a negative exponent. So we're going to bring this guy down to the bottom so that is no longer negative, and we will be left with 2x squared x minus 3 all over 5, and there's our final equation. So we have this ugly guy is equivalent to this expression down below, as long as we include those restrictions. So taking a look here at these denominators, we can see that x can't be equal to 0. So we already have one restriction. We know x can't be equal to 0. Over here, it's not factored, so it's hard to see. So let's look below. So we have x can't be equal to 0. Here we have another restriction, x can't be equal to 0, so we've got that one. And here we know that x cannot equal 3. So we're not done though, because we flipped this fraction. Now the numerator has become the denominator and the denominator has become the numerator. So we have a new restriction that's created over here, which is why I've suggested that you factor before you flip. Otherwise, sometimes you're going to miss the restrictions from the original denominator. So taking a look here, we have a new restriction, and that's going to be -3. So a restriction is positive or -3. So let's just take a final look. We have x can't be 0, x can't be 3, x can't be -3, and everything else we've gotten. And we've made it to our last two examples. So what I'm going to do is I'm going to leave these with you, factor them, and then come back to the video so we can start simplifying. So once you factor the expressions, it should look something like this. X squared minus 4, that's just a difference of squares, so that's what it factors to. We have a common factor in here, 3, so this is, when we pull that out, this is what we've got it factored to, and there's nothing to factor in these two binomials here. So we're left to multiply these two, so we're going to multiply the first ones and multiply the second one. Really important, add some brackets here, so there are implied brackets. So when we multiply them, the numerator is going to be x plus 2 times x minus 2 times x plus 3. And remember, we don't want to expand anything because we want everything factored so we can look for common factors in the numerator and the denominator. So we have x plus 2 times x minus 2 times x plus 3 in the numerator. And in the denominator, we have 3 times x plus 3 times x plus 2. So we have 3 times x plus 3 times x plus 2. And now is the easy part. We got to look for common factors. So I see an x plus 3 and an x plus 3 in the numerator and the denominator. We can cancel those out. I see an x plus 2 and another x plus 2. We can cancel those out. And so all we're left with in the numerator is this x minus 2. So I'm going to write x minus 2. And all we're left in the denominator is this 3. So everything simplifies really nicely. So we have this lovely expression is equivalent to these expressions multiplied together, as long as we include those restrictions. So we're going to say this is only true if x cannot equal. Take a look at the top. Okay, this is not factored, so it's difficult to tell, but we can tell here that x can't equal -2. Let's keep on looking down. Now that we have this factor, we can see x cannot equal -3. So we're going to add -3 to our list. We're going to keep going. X can equal -2. We've got that one. -3, -2. We've got everything. So here's our final answer. And we have our final example. So we've got a division problem. We've got 4 different expressions that we've got to factor, and then we're going to divide and multiply. So I'm going to leave you to factor them. Pause the video, come back once it's factored. So once you've got everything factored, you should have something that looks like this. So we've got our 1, 2, 3, 4 expressions factored. So now that we have them back into our rational expressions, we're ready to divide. So we know we're going to flip and multiply. So I'm going to rewrite this first guy as m minus 4, m plus 1. So this guy doesn't change. And then m times m plus 5. And then we are going to change the division sign to a multiplication sign and flip this fraction. So our numerator is now going to be m minus 3, m plus 5. And our denominator is going to be m minus 3 and m minus 4. So you can already see those m minus 3's are going to cancel out. If you want to do that now, you can do that now. So let's just multiply these two. And if you can multiply them in your head and visualize what they're going to be already, you can go ahead and skip this step. But if you need to write it out, our numerator is going to be m minus 4, m plus 1, m minus 3, and m plus 5. And our denominator is going to be m, and then we have m plus 5, m minus 3, and m minus 4. And now we're ready for the fun part, which is crossing out. So we have m minus 4 common factors. We have m plus 5 and m plus 5 also common factors. And we have m minus 3 and m minus 3 common factors. So the only thing we have left on the top is actually m plus 1. And the only thing we have left at the bottom is just m. So we're going to put m. So do not cross out our m's. So don't think, oh, I can cross out m, I can cross out m, because m is not a factor in the numerator. M plus 1 is the factor. So it's not, if m was being multiplied by 1, then yes, we could cross out, but m is being added to 1, so the factor is m plus 1. So these ugly expressions just factor out to this or cancel out and simplify into this beautiful, simple, rational expression. So they're completely equivalent as long as we put restrictions on our m. So let's start up at the top. We're going to have a bunch of restrictions here. So let's start over here in this denominator. Up here it's hard to see because they're not factored, so let's start where they're factored. We know m can't equal 0. Here we know m can't equal -5. Moving on, we have m can't equal 3. And we have m can't equal -5. Again, we've already got that one. Moving down, we have m can't equal 0. Got it. -5. Got it. 3. Got it. 4 we don't have. So we've got to add m also cannot equal 4. And if you take a look again, there shouldn't be any new ones. So we have m can't equal 0, -5, 3, 4, and we've got all of them.